Investigation of Curves, Section 2, Derivatives of Curves. Video 4, Equations of Tangents, Chords and Normals. A lot of what we're going to look at in this video is likely to be fairly familiar to you, just applied in a slightly different context from what you might be used to. So when you're working out the equations of tangents, chords and normals, all you need to do is to use dy by dx to find the gradient function, and then substitute to find the gradient at a particular point, and then use what you already know about equations of straight lines. The only difference is that you're going to be using your formulae for dy by dx if you've got parametric or polar coordinates that we covered in the previous videos. So if you're asked to find the tangent or the normal at a point x1 and y1, first of all you're going to work out dy by dx to get the gradient. If it's a normal, you're going to use the negative reciprocal to find the gradient at right angles to the tangent, and then you can use the formula y minus y1 equals m times x minus x1, where m is the gradient that you've worked out. Sometimes you're going to be asked to work with chords. In that case, you need to use y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1, where x1, y1 is one point on the chord and x2, y2 is the other point on the chord. Let's work through an example of this. So find the equation of the tangent to the curve with parametric equations x equals t squared plus 1, y equals t minus 1 at the point where t equals negative 1. Now I could use my computer algebra system here, but I'm just going to do things by hand for this example. So to work out the gradient dy by dx, I need to work out dx by dt and dy by dt first of all. So dx by dt is going to be 2t, dy by dt is going to be 1, so dy by dx is dy by dt divided by dx by dt, so that's just going to be 1 over 2t. Now I'm asked to consider the point where t is minus 1, so at t equals minus 1, x equals, well, t squared is 1, 1 plus 1 is 2, y is t minus 1, so y is negative 2, and dy by dx is 1 over 2t, so that's minus a half. I've been asked to deal with a tangent here, so I don't need to worry about it being a normal. I'm going to have a gradient of minus half, so I can just use y minus y1 equals m x minus x1. So y minus negative 2 equals my gradient x minus 2. And simplifying that just gives me y equals minus a half x minus 1. So let's just look at that written out neatly. So I started off by working out dx by dt, dy by dt, and using those to find dy by dx by dividing this by this. Then I looked at the particular point I'd been asked to find, which was t equals negative 1. And I found that x was 2, y was negative 2, and dy by dx was negative a half. So then that gave me the tangent using y minus y1 equals m x minus x1, simplifying to y equals minus a half x minus 1. So in this video we've had a reminder of how to find the equations of tangents, normals and chords.